Welcome back, everyone. Today we are going to be learning about ellipses, which is our second conic section that we're learning about in this chapter. The ellipse is just another way to say oval. So it's just a mathematical term for an oval, so an elongated circle in a way. Ellipses can be defined geometrically, just like we did with parabolas. An ellipse, again, we'll write down the geometric definition, and then we'll take a look at what these words mean using a graph. So our geometric definition for an ellipse is the set of points, again, in a plane where each point, where the sum of the distances from each point to each focus. So we're going to have 2 points that each one is going to be a focus for an ellipse. The distances, the sum of distances from each point to each focus is constant. So no matter which point you pick, the sum of the distances is going to equal the same number, some constant number. And focus means something different here for an ellipse. Similar to parabola, the focus, or the two foci that we're looking at. So foci is just plural for focus. So if we have two focuses, we would say two foci. The two foci that we have for our ellipse define the ellipse. So we pick two foci, and then there's going to be one unique ellipse that matches that. Let's take a look at what that means geometrically. So just thinking about an ellipse. So here we have an ellipse, not the perfect one, but still. If we pick any point on this ellipse, for example, let's pick this point here, P. For this ellipse, there are two foci. We could call them F1 as one focus. The other one could be called F2. Here, the distance between our point and F1, we could call D1. The distance between the point and F2, our second focus, could be D2. In this case, D1 plus D2 is equal to some constant. We could say, let's just call it capital D. So D1 plus D2 is equal to capital D. And no matter which point you pick on our ellipse, when you add those two distances up, you'll get the same constant value. So if we picked another point on our ellipse, for example, we could pick a point down here, P. If we look at the two distances, here we have D1 for P. Here we have D2 for P. If we were to add these two distances up, we would end up with that same constant, D. So the sum of those distances is constant for every point on our ellipse. One way to draw an ellipse is to set 2 points. So you could tape, for example, the ends of a string, and then the string has a constant length, which is the sum of these distances, and then you can use a pencil to trace around the ellipse. And it'll form an ellipse because the sum of the distances will always be that constant value, the length of the string. So let's take a look at the equations that we see for ellipses and do a practice problem with answering some questions about an ellipse. So first, I actually want to talk about some key vocabulary words that we use to describe ellipses. We, of course, have the two foci. So F1, for example, could be here. F2 is here. We also have the distance here, or this line here, is what we call the major axis. And that's going to be the longer direction, in the longer direction. So the major axis is the axis in the longer direction. If we had a an ellipse that was vertical. So something like this. Then our major axis would be up and down here. The other axis, so perpendicular to that, in this case up and down, is what we call the minor axis. And this is our shorter direction. So the minor axis to the right would be this axis here. We can also talk about the x radius and the y radius, which is always in the horizontal and the vertical direction, respectively. So the x radius is going to be the distance between the center and this edge of the ellipse. The y radius is the distance between the center and the y, kind of like edge that we see here. So x radius and y radius. Finally, when we talk about the vertices, so there's a vertex on each end. The vertices are going to be these points here at the ends of the major axis. So if we look in the longer direction, the very end of our ellipse is what we call the vertices. So here we have a vertex, and here we have a vertex. To the right, our vertices would be up here at the top and on the bottom. So major axis longer, minor's shorter. X and y radius is the distance from the center to a vertex, which is also half of the length of the axis. And then finally, the vertices are those points at the longer end of our ellipse. Okay, so now taking a look at the equation for ellipses. Our equation is what we see up here. So up at the top here, we have x minus h squared over a squared plus y minus k squared over b squared equals 1. So our equation for an ellipse takes this form. And if our equation is written differently, we can rewrite it in this form by completing the square. Unfortunately, we don't have a lot of time, so we're not going to go through that process. But in this course, we'll just be given an equation of this form, and then we can identify some key pieces of information from this equation. To the right, for example, the center is going to be h comma k. So again, we have the h and the k values next to that x and the y. A is our x radius, so the distance from the center to the ellipse in the x direction. And then b is the y radius. This is from the center to the ellipse in the y direction. And then we can tell that our ellipse is horizontal if a is bigger than b. And this is true because if a is bigger than b, then our x radius is larger than our y radius. So it means it's going to be elongated in the horizontal direction. The opposite means that we have a vertical ellipse if our x radius is less than our y radius. To find some key pieces of information, what we can do, for example, if we're trying to find the vertices, then what we can do is look at the center, and then if it's in the x direction, we're going to be adding that x radius. So so h plus x radius, which we labeled as a, h plus a comma k, and h minus a comma k. So we're taking that center, and then we're adding the x radius to the right and the x radius to the left. And that's how we find the two vertices. For a vertical ellipse, it's the same idea, except we're starting at the center, and then we're adding we're adding in the y direction. So h comma k plus b, our y radius, h comma k minus b. So those are our vertices. Finally, to find the foci, to find each focus for our ellipse, we can look at this distance. Let's see, this distance here between the center and the focus, which we could call c. And we have an equation. We're not going to go through how to derive this equation, so I'll just give it to you. We have an equation that tells us that c squared is equal to a squared minus b squared. So the x radius squared minus the y radius squared. And that's if we have a horizontal direction. If it's in the vertical direction, Then we have c squared equals b squared, so the y radius squared minus the x radius squared. And we can see this through some right triangles, which we won't go into detail right now. But we can use this equation to find c, which is the distance between the center and the focus, each focus. And then to find the focus, what we can do is, or to find the two foci, we can take our center, and then in the x direction, we're going to be adding on c and subtracting c. So we add on c, go to the right by c, and also go to the left by c. And same thing for our vertical direction, except we're just adding on or subtracting from the y direction. So k plus c, h comma k minus c. So our two foci are going to be plus c and minus c up here and down here. So this is how we can look at the equation of an ellipse and then identify some information about it, find what direction it's facing, the x radius, y radius, the center, and then we can also use the x radius and the y radius to find where the two foci are. And the foci are what define our ellipse. So given two foci, there's a unique ellipse that matches our definition. So finally, I want to go over a quick example of how we can use this information to answer questions. Okay, so an example of how we can use this information is we might be asked to graph an equation of an ellipse. So right away, what we can do is identify the center. We know that the h value of the center is x minus h. So in this case, x minus 2 means that 2 is our h value. The k value is, or in the y direction, the y value is going to be y minus k. And because we're adding 1, that's the same as y minus negative 1. So negative 1 is our y value for our center. We can also identify the x radius. We know that a squared is the number that we see down here. So a squared equals 4. So our x radius is 2. The y radius squared is what we see down here. B squared is 16. So b is 4. And we're only looking at the positive square root because the radius is a distance. So just a positive number. So we have our two radii. Then finally, we can use this information to graph our ellipse. So we know 2, negative 1. Negative 1 is our center. We know that the x radius is 2. So 2 to the right is 4. 2 to the left is 0. So we start to graph our ellipse. We know we'll have points 2 to the left of our center, 2 to the right of our center. And then the y radius is 4. So if we go 4 up from negative 1, we get to positive 3. If we go 4 down from negative 1, we end up with, oops, I'm just going to extend this, negative 5. So we have a point from the center. We go up 4 to negative 3, or sorry, positive 3. And this is one of our vertices, 2, 3. And our other vertex is going down by 4. So 2, negative 5 is our other vertex. And then finally, our ellipse would look something like this. So just connecting our vertices and the edges that we see down there. So not a great ellipse, but you get the idea. How we can take some information from our equation and then graph the ellipse based on that information.